For additional information, the video that soon will be showing that the topic related to site reduction laboratory.
Hello everyone, thank you for taking the time to watch this video. This presentation will describe our site reduction laboratory that we are making laboratory recording. Today, I'm here with my team, Methavi Sivilat, Pincha Chanakchai, Chayira Sritranun, and Thai Natapakun Maribu. First of all, when you think about chemical engineering, you will think about petroleum, right? Even though petroleum is the main idea, but the site reduction is the overlooked aspect of chemical engineering. And the topic chosen is effortlessly understandable for regular audience. About the objective, to guide the part sugar down into the smaller side by using the ball mill, and to obtain the particle size distribution of the initial and the final safe mixture. Ball milling is a method used to break the solid down to smaller size or into the powder. A ball milling is a type of guider which consists of cylinder. It is used guiding material like ore, chemical, semi-raw material, and paint. In this experiment, we are required to break the hard sugar down to smaller size by using ball mill and then by using the sieve. Today's presentation covers four themes. Methavi Sivilat will talk about theoretical background. Chayara Sutitranon will talk about chemical equipment and experiment procedure. Pincha Chanakchai will talk about the result, and the question will be asked at the end of the presentation. Looking at each of these four themes in turn, starting with theoretical background, I will hand over to Methavi Sivilat.
As for the theory, the ball mill consists of guiding pods that rotate slowly horizontally in the closed system, in which the grinder has a ball inside. By grinding using the principle of impact of the ball with the distal particle, when the grinding pod begins to rotate, the ball moves up to the wall of the guiding pod and falls down. Grinding is caused by two forces, which are centrifugal force that cause particle and ball to roll against the grinding pod wall, and gravity force that cause the ball to fall at the bottom of the grinding pod, which will cause impact. Usually, the rotation speed of the grinder is less than the critical speed, because if using the speed that is equal to the critical speed, the ball will be toward the wall all the time, which will cause very little or no impact grinding. This condition is caused by grinding the velocity equal to the velocity of center escape. Therefore, the speed is called critical speed can be calculated using the equation nc equals 0.4985 multiplied absolute 1 divided by radius of pod minus radius of ball. Finally, the result that shows in the relationship between percentage of critical speed with filling.
Then, we will talk about chemical and equipment. Chemical and equipment as follows. First, sugar. Second, a ball mill. Third, a set of standard screens. Fourth, a testing sieve checker. Fifth, a balance. And the last is a measuring cylinder. Next, we will look at the most important part of this project, that is experiment procedure. And it can be divided into three main parts as follows. First, sugar density estimation. Second, ball milling. And the last is size classification. To start with part 1, sugar density estimation. We weigh sugar with a specified volume and estimate the density of sugar. And the next is part 2, ball milling. First, load 120 small size balls into the ball mill with 20 cm inside diameter. Second, weigh 200 grams of sugar and put into the ball mill. Third, set the operating speed of the ball mill to be around 70 to 80% of the critical speed. Fourth, run the ball mill for 10 minutes. And the last is change the balls to 50 large size balls and repeat step 2 to 4. The final is part 3, size classification. First, arrange a set of standard screens with the smallest made at the bottom and the largest one at the top. Second, put the unmilled sugar into the top tray. Third, put the arranged set of the screens into a tasting sieve shaker and shake it for 20 minutes. Fourth, weigh and record the weight of sugar remain in each screen. And the last one is put the milled sugar obtained of the ball milling section and repeat step 3 and 4.
Okay, next, let's see a result. This is the raw data that we obtained from the experiment. You will see the first column which covered with a lead frame. That is the particle size from side of each mesh. And in the blue frame, that is the weight of sugar in each mesh. Then we analyze the data in two graphs. The first graph is a differential analysis plotted between mass fraction and particle size. And the second graph is a cumulative analysis plotted between cumulative mass fraction and particle size. They show how the particle size distributes after using a ball mill. And we found that the large ball could make small size of sugar than mixed and small ball. After that, we calculate the specific surface, average particle size, and number of particles of the mixture shown in Table 2. You will see the large ball provide the highest specific surface, lowest diameter of particle, and highest number of particles. That means all particles got from large ball have a smallest size and most number if compared in 1 kiloparticle. In the conclusion, the size reduction of sugar depends on the size of the ball. The large ball will make finer sugar than a small ball, and we can conclude about the efficiency of size reduction by using a ball mill. Using large ball is best choice, followed by mixed ball, and small ball is last choice.
Here is the overall summary of the presentation. The important reasons for size reduction are easily handling, increase in surface area per unit volume, and separation in trapped components. The chemical, pharmaceutical, food, ceramic, and mining industry all rely on size reduction. Size reduction technology has considerable importance in the pharmaceutical field. Size reduction technology has an application in different fields like pharmaceutical manufacturing of novel and conventional dosage form. It offers several advantages such as content uniformity, uniform flow, facilitate mixing. The final selection of the equipment is based on the material and the quality requirements of the product. This brings the presentation to the end. Thank you for time here. Any question? If you like this video, don't forget to keep like and subscribe. Thank you.